In this video, we are going to talk about the another non-parametric test we call Mann-Whitney U test. So this test is basically used for two unpaired groups. You remember that we used the sign test for the paired groups, right? But for the unpaired groups, we usually use Mann-Whitney test. Okay. So it is based on the comparison of every observation x sub I in the first sample with every observation y sub j in the second sample. Meaning you take one observation and then see how many of these are bigger than that and how many of this data from the second sample are smaller than that. You count that way. Okay. The total number of pairwise comparisons that can be made is n sub x times n sub y. N sub x is the number sample size on the first sample and the n sub y is the sample size in the second sample. We count the number of times an xi from sample 1 is greater than yj from sample 2. This number is denoted by u sub x. But to find out u sub x, okay, we use slightly short, like brief formula, different formula than what we describe here. Similarly, the number of times that x sub I from sample 1 is smaller than y sub j from sample 2, that is we denote by u sub y. Under the null hypothesis, we would expect u sub x and u sub y to be approximately equal, meaning the number of data in sample 1 bigger than the number of data in sample 2. We expect that is equals to number of data in sample 2 bigger than number of data in sample 1. We expect those two numbers equal. Okay, that is u sub x. That is u sub x equals to u sub y. So to perform the Mann-Whitney U test, we rank all the data regardless of the group and find the sum of ranks in each group and find those values. We use the table specific to the Mann-Whitney table. We use, to find out the critical value, we use the Mann-Whitney table to find the critical values. The table for different values of alpha can be found at, this is the website for the table, okay, but I will present a page of that table on the next slide. Mann-Whitney U test on paired group is equivalent to Wilcoxon rank sum test. Okay, so we will discuss this. Basically, this Wilcoxon rank sum test we can find out in R. Maybe we'll be able to find out the Mann-Whitney U test in R, but I haven't looked for it. You can look if you want to. But this Wilcoxon rank sum test we can find out in R for the unpaired groups. Okay, all right. Let me go to the next slide. So what are the steps to do the Mann-Whitney U test, two-tailed test? I'm taking example of two-tailed test. The first step is write h sub 0 and h sub 1. The second step is rank all the data regardless of the group. So you put all the data in one group and then separate them later for the different group. Okay, so for the both group of data, you start to rank, putting them all together. In case of the tied rank, assign an average rank, and then next step is find the sum of the ranks from each group. The R1 is the rank in the group 1 and R2 is the rank in the group 2. Okay, calculate U1 by using this formula. Or you can find out U2 as well, where N1 and N2 are the number of data points in the two groups. Also calculate U2 using U2 is that. So U1 is calculated by this, U2 is calculated by this. Or you can do U2 is calculated by this and U1 by this. So either way. Choose the larger of U1 and U2 and denote that by U. That U is the test statistic. So the bigger of U1 and U2 is the test statistic. With given alpha and N1 and N2, find the critical values from the table. You will see the table in the next slide. Note that there is another type of table which rejects H0 if U is less than U critical, where U is smaller of U1 and U2. But let's not talk about that. We will look at the table I have given in the next slide. If the test statistic is greater than or equal to the critical value, then reject the null hypothesis. If the test statistic is bigger than the critical value, then we reject the reject 80. Otherwise we do not reject. Let's take an example. So on this example you can see the sagebrush cricket has an unusual form of mating. During mating, the male offers his fleshy hind wings to the female to eat. The wounds are not fatal, but a male with already nibbled wings is less likely to be chosen by females he meets later. Females get some nutrition from feeding on the wings, which raises the question, are females more likely to mate if they are hungry? Johnson et al. 1999 divide 24 females into two groups. One group with 11 females starved for at least 2 days, and another group of 13 was fed during the same period. Then each female was put separately into a cage with single male, and the recording of the waiting time of the mating is given below. Starved 1.9, 2.1, 3.8, and so on. Fed, these are the times that it takes to mate. Okay, so it looks like in hours, they are in hours. Right, at alpha equals 0.05, test the claim that the time of mating differs between those two groups. That's what you want to test. So what is the null hypothesis here? Is the time of mating is same for the female cricket that were starved and then that were fed, and the H1 is time to mating differs between the two groups. Here the no difference, here the time is different. Here the sample size in the group 1 is 11, sample size in the group 2 is 13. So rank all the data regardless of the group. How do you rank it? It is like smallest will be 1, right? So this is basically you rank it 1, this is 2, right? This is 3, this is 4, right? This is 5, because the smallest of the two group is 1.5, that is 1. Second smallest is 1.7, third smallest, fourth, fifth, and then this is 6th, right? 6th, and this will be 7, and then 8, and then 9, and so on. And you see that group 1 has the ranks 3, 4, 7, 9, 10, 11, and so on. And similarly, you can find out the ranking of the group 2. The remaining rank will be for group 2. And the sum of the rank 1 in the first group, the total of these ranks is 121. Now we find out U1 is 88. So do you remember the formula for U1? This is the formula for U1. N1 times N2, that is 11 times 13 plus 11 times 13 plus 11 times 11 plus 1 divided by 2 minus R1 is basically that 121. That's what you do, right? So and then you find out U1 that using that formula is 88. Also you find out U2. What is the formula for U2? Is N1 times N2 minus U1. N1 times N2 minus U1. So if you do that, you will get U2 is 55. So what is the test statistic? Is the bigger of U1 and U2. So bigger of this, and this is U1, right? This is U1, so this is U2. So the bigger of U1 and U2 is 88. This is the test statistic. Okay, now to find out the critical value, we have alpha equals to 0.05, N1 is 11, N2 is 13. I have the page of the table. See, alpha is 0.05, N1 is 11, N2 is 13, right? So this is N1 is 11, N2 is 13. So alpha is 0.05, two-tailed test. You see that? This is the value of, this is alpha equals to 0.05. Two-tail, alpha 2 is the two-tail, alpha 1 is the one-tail. So this is the value you get for the critical value. That is the critical value is 106. Now you see that U is the test value is less than U critical, right? So we do not reject 80. If U is less than U critical, we do not reject. If U is bigger than U critical, we reject. That's what the decision method, right? So the conclusion is, what is the conclusion? So conclusion is we do not reject, meaning there is no difference in the mating time for fed and unfed insects, right? So there are two problems. You guys do these problems basically. Do these problems. using R. Okay, you can do both of the problem using R. Let me show you how to do this problem, these examples or this method using R. So if you scroll down on line number 48 of the code, it says Mann-Whitney U test for 2 unpaired groups. Okay, this is same as the Wilcoxon rank sign test with independent samples. So it is also called Wilcoxon rank sum test as well. So what is the code you use? Is suppose there are two data X and Y. There is 1.83. So let me run X and Y data set so that computer can save it, and then go down and then do Mann-Whitney U test. So Wilcox.test X comma Y and then paired. This is not a paired test. So unpaired test, that's why we said paired equals to false, and confidence level is 0.095. If I run this, it says let's not worry about the warning message. What you get is p-value is 0.1329. Then what you get is your decision is p-value is greater than alpha, right? So we do not reject the null hypothesis.